Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Earlier today I was just kind of sitting in the sidelines listening to the chaos over on Dip's channel, and some interesting things came up that I thought might make a nice discussion. The usual characters were there, and they were talking about the rotating sky patterns as being quote-unquote proof of the rotating spherical Earth, and why, of course, they didn't mean that the Earth was actually spherical or rotating. So I thought I'd take a couple of minutes and talk a little bit about how we can all have a look at this and figure out some reasonable conclusions based on what we can see in the sky. Now, when doing a scientific inquiry, it is very common to take certain things as givens. These are well-proven, well-documented facts that we can take as gospel when it comes to looking at other things that are related to it. So an example of that is this program right here. This is called Stellarium. You can see the address for it up on top. And this is a very commonly used planetarium program. It's free and anybody with an internet connection can access it. Now, why do I just accept Stellarium as quote-unquote gospel? Well, I'm familiar with the program. I've used it for a number of years. In fact, I can actually point my telescope in the observatory using Stellarium, and every time that I have done that in the last 5 years, the object that I was looking for was directly in the center of my field. I have yet to find a single instance that if an object was in the Stellarium database, it was not where Stellarium said it was. And as such, I'm going to accept Stellarium as accurate from not only my location, but any location I choose to designate on the surface of the Earth. I've used it in a number of cities. It has never failed me once. Now, in this instance, I have set Stellarium up to be located in Marquette, Michigan, a place that I have personally used it many times with good results. I have turned off the sky so we're not getting daylight above the ground. I can also turn the ground off if I wish, but I'm going to leave it on just for reference. You can also see the cardinal direction that we are looking, in this case, north. I can also move it around to look west or east, in fact, but we'll leave it at north for right now. Now, this is today's date and time. I'm going to move the time forward through the day, and I would like you to pay attention to Ursa Major and Cassiopeia, which is right here. Now, as I move it forward, notice that we're getting a counterclockwise rotation in the night sky. Now, of course, this is nothing new. We all know that when we look north, the stars appear to rotate about Polaris in a counterclockwise motion. However, there's something interesting about them, and I tried to point this out to Gene Techman, but unfortunately, I don't think he really has the insight to be able to understand what I was talking about. Now, stars, planets, and all objects in the sky rise in the east, and they set in the west. So, for example, if we look at Cassiopeia and Cepheus, notice that as I move the time forward, they appear to rise to the east of the North Star, and then they move from right to left to the west. Now, rising in the east and setting in the west is perfectly normal for all objects in the sky. Gene tried to have me look this up or quote-unquote Google it to confirm that objects in the night sky rise in the east and set in the west, as if somehow he had found some sort of gotcha. Unfortunately, that's going to come back to bite him in the tail end. And I don't think he has the level of insight required to realize why it bites him in the tail end, but I'm sure he'll come up with some sort of an excuse. Now, here's the problem that I brought up, and again, I don't think any of them understood what the problem was. Let's look back over here at Ursa Major. Now, recall that this is the east side of the screen, and this is the west side of the screen. As a matter of fact, you can see the west right there, and north is right down here at the bottom. What happens to Ursa Major? What direction does it move? That's rather interesting, isn't it? It seems to be moving from west to east. Well, why is that? Where is the North Celestial Pole in this image? The North Celestial Pole is the pole star right here, and that is the center of this circular grid. Notice that if objects are above that North Celestial Pole, in other words, between the North Pole and me, they move from east to west. We'll go ahead and do that real quick. So those stars that are above the North Celestial Pole are clearly moving from east to west. However, stars that are below the North Celestial Pole move from west to east. Now, the answer to this is actually quite simple if you can think in 3 dimensions. The North Celestial Pole, as you know, is directly over the North Pole of the Earth. Objects that appear above the North Celestial Pole in the sky are over the Earth between the North Pole and me, at least until you get to my zenith, in which case they actually start becoming south of me, but on this side of the Earth. But what about constellations that are below the North Celestial Pole in my sky? For example, the constellation Cygnus, Ursa Minor, and Ursa Major are clearly below the North Celestial Pole. They're between the pole and the horizon. Where are they located? Now, the answer to this question should be rather obvious if you can think in 3 dimensions. But what about the objects that are below the North Celestial Pole? They are very clearly on the other side of the Earth from the North Celestial Pole from me. So, for example, if we look at the constellations Cygnus, Draco, and Ursa Major, these are all clearly below the North Celestial Pole to me. Now, if instead we view the North sky from Moscow in the Russian Federation, let's go ahead and pick out these constellations again. Here's Cygnus. It is still below the North Celestial Pole. Here is Draco, which kind of is due east of the North Celestial Pole. And here is Ursa Major. It's again above the North Celestial Pole. Now, Moscow is not directly over the pole from me. It's close enough, but you can see that clearly, especially in the case of Ursa Major, we've gone from being below the North Celestial Pole to being above it simply by going past the pole to the other side of the Earth. And of course, once again, if we look north and move time forward, we get that exact same counterclockwise rotation. The stars are not mirrored. The constellations look exactly the same in Moscow as they do here. Now, this is very easy to explain on a flat Earth model, given the fact that, say, Ursa Major is over the Earth at a point that's on the far side of the Earth from the North Celestial Pole from my location here in Michigan. However, we do run into a little bit of a problem when we go down to Sydney, Australia. Let's go ahead and have a look. Okay, so now we've gone from Moscow to Sydney, Australia. And again, we're looking north, that's west, this is east out here. Now, one thing that we can do as we move the time forward is notice that we have that same counterclockwise rotation. Now, as we come through, are we going to see any of our constellations? Well, there's Cygnus right on the horizon. And it doesn't look like we can quite see the Draco or Ursa Major. Oh, maybe Ursa Major's coming up here. We do get a little bit of Ursa Major. Hang on. It's all the way in the back here. So here's Ursa Major just to the right of the north. And you can see just the feet as it passes by the horizon. Notice that we don't see the North Celestial Pole, which is down here. As a matter of fact, I can turn off the ground, and you can see where the North Celestial Pole is. In fact, it might be interesting. Let's go ahead and take the ground off. There's Ursa Major. There's Draco. And there is Cygnus. And they're all moving counterclockwise, just as they did in the Northern Hemisphere. The only problem is the North Celestial Pole is well below the horizon. But let's go ahead and turn this south. So what do we have here? We have another celestial pole, in this case, the South Celestial Pole. Let's go ahead and move that forward. Look at that. It's moving in a clockwise direction. Now, once again, we're looking south, and here is west. That implies that this is east over here. And if you look above celestial pole, up here by where Carina and Centaurus are, let's go ahead and move the time forward, and you'll notice that the stars are now moving in a clockwise fashion, and above the pole, they are moving from east to west. However, as before, if we look below the pole, they're moving from west to east. Let's go ahead and look at that one more time and pay attention to the stars that are underneath the south celestial pole. They are very clearly moving from west to east. Now, what conclusions can we draw from this? Well, exactly the same thing that is happening at the north celestial pole is happening in the south celestial pole. The objects that are moving from west to east in the north celestial pole are on the other side of the North Pole from my location here in Michigan. The objects that are moving from west to east from Sydney, Australia, are on the other side of the pole, the South Pole, from Sydney, Australia. So while all of the objects are indeed moving from east to west, the fact that we're looking past the pole to the other side of the Earth makes them appear to be moving in the opposite direction because they're on the other side of the Earth. This is completely incompatible with any model of a flat Earth. Now, one last demonstration I would like to make is, let's go to Union Glacier Airport in Antarctica. This is where the final experiment was done last year, about this time of year. Let's go ahead and have a look and see where the sun is. So here's the situation today, December 16th at 12 a.m. Notice that this is north, and that is the location of the sun. What happens as we move time forward? Now the sun is in the west. Let's go ahead and move it forward here a little bit more. As we continue to move forward, the sun is now due south of Union Glacier at 80 degrees south and above the horizon. Now this is a very telling observation. The sun is above the horizon and to the south of Union Glacier, which is at 80 degrees south. It is beyond the South Pole. However, the sun never leaves the Tropic of Capricorn and the Tropic of Cancer. It's always up by the equator. Why are we seeing the sun directly south of 80 degrees south at Union Glacier? Let's continue to watch. Now, once again, the sun is due south and above the horizon. Let's go ahead and bring this over so that we get to the east. And now we'll continue to move the clock forward. Again, sun is above the horizon. Now it's directly east. Let's bring it back here. There's north. And we're coming up on 10 o'clock. And there we are at midnight again. The sun is in the north, and the sun never set during the entire 24-hour day. So there are two observations that absolutely rule out the possibility of a flat Earth. We have apparent west to east star motion between the horizon and the north celestial pole and between the horizon and the south celestial pole. We also have 24-hour sunlight at Union Glacier, Antarctica. And the sun indeed appears due south of Union Glacier at some time during the day. That is simply impossible on a flat Earth. So, this is Bob the Science Guy. Better luck next time. I hear Bigfoot is looking for supporters, flat Earthers. Maybe you can find a home there. Take care.